Today we're going to talk about Pythagorean identities as we solve for different parts of triangles and angles. What we want to write down first is this formula. So if you've got your notes, you can put it maybe on the back of your unit circle would probably be a good spot for this. But the Pythagorean identity is this: sine squared of x plus cosine squared of x equals 1. So this is our Pythagorean's identity, and the reason why it's called a Pythagorean identity is because it is Pythagorean's theorem. It is a squared plus b squared equals c squared, but we've got to think about what our values are. Our sine values are our first term, our cosine is our second, and then our hypotenuse is always 1. So when we square 1, it remains 1. So that's where the Pythagorean identity comes from. So we're going to use the Pythagorean identity because we're dealing with the unit circle to determine the certain parts of our trig values. All right, so this is your first example on your Delta Math assignment. You see I've got a nice little unit circle here for myself. You don't have to necessarily have the unit circle, but I find it's a lot easier for me when I know what my answer is going to be right off the bat. Let's not forget our coordinates or quadrants. The first quadrant is in the top right. This is our second quadrant. This is our third. And then lastly, our fourth quadrant. So these are the different quadrants. And what we are asked in this, given that a cosine value of -2/3 and an angle of theta in the third quadrant. So what we're looking at here is this section right here. We're looking in the third quadrant. And this makes sense because it said our cosine value was -2/3, which this is the, remember, cosine is negative on this side of our origin. And what we're asked to do is to find the exact value of sine of this same angle in the simplest form. Here's why I like to see this. I like to know, okay, I'm looking for a sine value, and the sine values are the y values. And if I'm in the third quadrant, the y values are negative. So I automatically know that I'm going to get some kind of a negative answer on this particular question. So what we do is we take our value of cosine and we put it into that Pythagorean identity formula, which says sine squared of x plus cosine squared of x. And I'm not going to rewrite this formula over and over again. I'm going to do it for this first example, equals 1, because we do have the unit circle, so our radius is 1. So 1 squared stays 1. On this question, we are told that cosine is -2/3. So what we're going to do is replace our cosine with its own value, which is -2/3. We technically call this 1 squared, but 1 squared, of course, stays 1. So we're going to do the math that we know, sine squared of x plus, I'm going to zoom in here so we can see all of this, -2/3 becomes 4/9. And as we said, 1 stays 1. So we're solving for x, so the next thing we need to do is subtract 4/9 from both sides. Now 1 is 9/9, so if I subtract 4/9 from 9/9, what I end up with is 5/9. So sine squared of x equals 5/9. Now I've got to get x by itself. So what I'm going to do is take the square root to get rid of this squared term. When I square the sine squared value, I get sine of our angle equals, well, the square root of 5 stays the square root of 5. The square root of 9 becomes 3. And one thing you want to keep in mind as you get these answers, remember the hypotenuse is the denominator for the cosine and the sine. And you can see that both of these do have equivalent denominators. The sine and cosine should, because their denominator is the hypotenuse. So what we have here is square root of 5 over 3. Well, this is not correct, and this is why we talked about it at the beginning, identifying what we're going to have. And remember, we're in the third quadrant, so our sine values are always negative. So this is actually going to be negative square root of 5 over 3. The reason why it is negative, because remember, when we square root a value, it's actually plus and minus the square root of 5 over 9. And in this case, we are taking the negative version because the negative version is the one that's in the third quadrant. There's a lot going on here. Make sure you do ask questions on these things, but don't forget to think in simplest terms. Remember, the cosine is still the x value. The sine is still the y value. So always pay attention to what quadrant you're in, and you're going to be able to determine if your answers make any sense. So let's take a look at our next example as well. So we are given sine of an angle is negative 35 over 6, and the angle is in the fourth quadrant. So I'm going to go ahead and highlight the fourth quadrant. That would be this section right here. And the sine values are negative there, which we just discussed. And what we're going to be asked to find is, what is the exact value of cosine? Well, the cosines that are on the right side of the origin over here, the cosines are always going to be positive. So this answer should be positive when we're done. Another thing we want to consider is that there is some reducing that happens from time to time. But remember, the hypotenuse according to sine is 6. So cosine is probably going to have a hypotenuse of the same amount. So we are going to take this into the Pythagorean identity formula. So it is sine squared plus cosine squared equals 1, or 1 squared, which stays 1, of course. This one tells me that sine is the square root of negative 35 over 6. And then we are going to square that value. Cosine, of course, stays cosine squared, and 1 stays 1. So this is the setup to our question. Now, when we square this fraction, and this fraction has a couple of things, the fraction also has a radical on top. So we are individually going to square the numerator and the denominator. So when I square the square root of 35, what I get is 35. When I square the denominator 6, I get 36. When I square a negative term, it then becomes positive. You should always get positive numbers coming out of this portion of the formula. Just like Pythagorean's theorem, you should have gotten the same thing. So it's going to be equal to 1. So as you do these, guys, you should be able to do these mental math. Because the number on the right side is always 1, we are going to subtract 35 over 36. And 1, of course, is 36 over 36. So when I subtract 35 from 36, what I end up with, is cosine of an angle of x, excuse me, equals 1 over 36. In order to get cosine by itself, we need to take the square root of both sides. And don't forget, when you take the square root of 1, it is 1. This is, of course, plus or minus. Well, the square root of 1 is 1, and the square root of 36 is 6. So this actually becomes the number 1/6. So our answer is either positive or negative 1/6. Well, since it's cosine, which is the x value, and we are in the fourth quadrant, the x values in the fourth quadrant are always positive. And again, that's why I like to start this thing off knowing what the answer is going to be, the sign of the answer is going to be. So cosine of our value is going to be positive 1/6. As we look at this one, it looks like a very different question, but really it's the same thing. We're substituting our degrees with radians, and we're substituting our fractions with decimals. But all in all, we're looking at the same type question. We're not asked to give the quadrant on this one. What we're asked to do is to put it between certain radian measurements. So let's first of all see what we've got here. It says use the identity to find the value of cosine of theta to the nearest hundredths when or if sine is equal to 0.42. And then here's the next part. When we are between half pi, which is right here, and 1 pi, which is right there. So essentially what they just told me was in the second quadrant. So let's talk about what they asked for. They asked for cosine. Well, cosine in the second quadrant is always negative. So even if I don't remember any of this thing, if I have multiple choice, keep that in mind. Cosine's negative because we are in the second quadrant here. All right, so we are actually going to do this exactly the same. We are going to set up our formula, which is sine squared of theta. We're using theta here, x and theta, they're both variables, plus cosine of theta equals 1, because we are still dealing with the unit circle. Well, they told us what cosine or sine was, it was 0.42. We're asked to find what cosine is, so we'll deal with that. And 1, of course, is 1. Going to obviously need a calculator here. When we square 0.42, we get an irrational number, by the way, but that irrational number is 0.1764. Plus cosine squared of theta equals 1. So we need to get cosine by itself. So we subtract 0.1764. And really, once I do this, I have to start using approximation signs, because the number is actually an irrational number. So we are now approximating our values. Calculator is going to be doing a lot of work for us here. 1 minus this value, and if you want it to stay accurate, what you could do, just a little side note here, to stay accurate, you could have went 1 minus 0.42 squared. That's going to keep you accurate, 100% accurate, just a little bit longer. So when we subtract 0.1764 from 1, we get 0.8236. And just like on the last one, we have to square root to get cosine by itself. So cosine of this angle is equal to, remember this is a plus or minus situation, but we said this from the beginning, we are in the second quadrant, and the cosines in the second quadrant are all negative. So we will take the negative version of this answer. The square root of that number is 0.91. And as I said, but didn't change, we now are dealing with approximately negative 0.91. That would be your third example from your Delta Math assignment. All right, last example we're going to look at today. So if you remember yesterday when we were dealing with the trig identities and we were just setting up the fractions inside of our unit circle, tangent was always much easier because tangent, we didn't have to solve for the hypotenuse because it doesn't need a hypotenuse. Well, on this one, not so lucky. Tangent is the trickier of the two. So let's read what we're doing. We're using the trig identity to find the value of tangent to the nearest hundredths. If sine is this, and we are in between pi and 3/2 pi. Well, here's pi. Here's 3/2 pi. So we are talking about the third quadrant here. So right away, in the third quadrant, tangent is always positive. Tangent's positive in the odd numbered coordinates. 1 and 3, tangent is going to be a positive answer. So even if I don't know anything about what I'm supposed to do here, I should be able to determine that tangent is equal to a positive number. And remember, tangent of the angle is equal to the y value divided by the x. So the y value is negative in the third quadrant, and the x value is negative. So when a negative divided by negative, it becomes positive. All right, so here's what we've got to do. One, we've got to keep this in mind because this is what we're going to have to fall back on, just like that. So we need to find what the cosine value is, because once we have the cosine value, we'll write this another way as well, because we do need to know this as well. Tangent of an angle is also equal to the sine value divided by the cosine value. And we did write that on your unit circle. So we've actually got a piece of this already because we know that sine is 0.78. So tangent will be equal to whatever we find cosine to be will be our denominator, but our numerator is going to be 0.78. And then this is what we need to find in order to construct our tangent. So just like all of the other ones, what we're going to do is use the Pythagorean identity, and we're going to put the cosine underneath of the sine, and then we'll have tangent. So sine squared of the angle plus cosine squared of the angle equals 1. Well, we've already established that sine is negative 0.78. It's very important that you use parentheses here, by the way. You start using non-parentheses, your calculator is going to give you negative numbers because you told it the wrong thing. We'll minimize this down in just a little bit, but let's just take a look at what we've got. When I square a negative 0.78, I get 0.6084 plus cos squared of an angle equal to 1. We then will subtract 0.6084 because we're trying to get the x by itself. And I know some of you are stressing right now. You're not doing much work. Your calculator is doing a good bit of work. But really, if you think about it, all we've done is squared a number and subtracted it to the other side. That's not a difficult process. A lot of times we mistake in these weird decimals and fractions on the first two as being something that is difficult, but we're taking very small steps here. All right, and then the last thing, we need to get cosine by itself, but it's cosine squared, so we need to square root both sides. When we do that, we learn that cos of our angle is equal to plus and minus 0.6257795, goes on for a little bit here. We said plus or minus, but this is cosine, and we are in the third quadrant. So the cosines in the third quadrant are always negative numbers. So the cosine of ours is going to be the negative version of this answer. Now you see I've written a lot of decimals out here. The more decimals you leave in, the more accurate your number is going to be. So here's the thing about tangent. We worked really hard to get that number. Our calculator did, actually. But we took a lot of steps to get to that number, but that is not the solution. Remember, that was the missing part to the tangent that we had earlier. It is the denominator for our tangent value here. So we'll carry this down so we can see it. Try to keep it all in one picture here. There we go. So tangent is the sine value, which was negative 0.78, over the cosine value, which is negative 0.6257795. And again, our calculator is doing the work here. Tangent of this value. Now we have approximations because we did use irrational numbers. Negative divided by negative is positive. So we have a positive 1.24644454, but we were asked to round to the nearest hundredths. So our answer is tangent of this angle is approximately 1.25. So there you have it. I know this is, for some of you, just kind of blowing your hair back, so to speak. But one thing I do want you to make sure you gather from this is know when the cosines and the sines and the tangents will be negative and or positive. All right. Didn't give you a real large assignment today, so make sure you do those. Put your paper down, put your work down on another piece of paper. If you're having a hard time getting these right, show it to me. Maybe I'll be generous to you. Good luck.